Hi everybody. Just a quick reminder to turn your cell phones down and write your evaluation forms at the end. And that's it. So I'm Jonathan Ba. I'm a generalist programmer at Ubisoft Montreal. I've worked for about 3 years on the camera system of Prince of Persia. And I'm very happy to be here today presenting you Directing the Prince of Persia-Camera, a sustainable development approach. I think you may wonder what I mean by by sustainable development and how it relates to camera development. So I'm just going to give you a quick introduction, a quick history of what we did on Prince of Persia. And the thing is, we started about 4 years ago now on Prince of Persia, and we started with the Assassin's Creed engine, which is called Scimitar. As we have the same kind of game, we have an adventure game, we have acrobatics, we have fights, we have all those things. It's a third-person game. So we really thought that it would be easy to reuse their techniques and their code and their data for cameras. And actually, it was not that easy at all. And we tried for about 6 months to work with them and try to come up with solutions that would be good for them and for us. And actually, after 6 months in the same company, we couldn't do it. So when we saw that, and we said, okay, we need to do something better. And also, we had 1 more year for Prince of Persia, so obviously we had more time to redesign something. And we really wanted to create a system that would be reusable by other projects in Ubisoft for later use. So that's the idea of sustainable development, and hopefully at the end of the presentation you have a better idea of what it implies. So the presentation is going to be organized this way. First, I'm going to talk about what were our needs for Prince of Persia. So filming the experience is going to explain you what we wanted to achieve with the Prince of Persia camera features. Then I'll talk about the camera engine, which is a bit different than a simple camera system. What I mean by camera engine is I want to have something that the camera features are going to be reusable by other projects, much like any other engine. We create a set of features, and we want to pick one feature for one game and another for another game. So we wanted to have the same thing with the camera features. Then I'm going to explain how we did it, how we created that camera engine. So first I'll talk about the camera mechanics that we have in it, how we designed them. I'll talk about triggering. How do you decide which camera is active at a given time? So this is triggering. And I'll talk a bit about transition, and at the end I'll talk about the artistic workflow, what we gave to our camera artists, and what they could do in the engine. And it's really important. This part is really important because in the end they make the game. And at the end, as a conclusion, I'll talk about sustainable development, what I mean by that. So first, filming the experience. What we wanted to create on Prince of Persia, we wanted to create something that is a bit more than a game, something that is more artistic than most of the games that we've created in the past. And we won the award for visual art, so that's kind of what we wanted to do. So here's a quick trailer on Prince of Persia. Just focus on, I'm sure you guys saw this trailer, just focus on the camera features. So first thing, we wanted to create something that is very cinematic. So we wanted very beautiful vistas. We have huge palaces and things like that, so we wanted to show that in a beautiful way. Another thing that we wanted to have is a certain sense of fluidity. So you can see here, the prince is running on walls, is jumping everywhere. There's a lot of acrobatics, and we wanted to have a camera that really shows all of this in a very fluid, fluid way. We also wanted to show gameplay elements, such as here, once you are on a column, you want to see the next gameplay ingredient you'll have to use. During the fight, we also had some interesting things to show. We wanted to show the combos in a very cinematic way. So you can see here the interaction between the prince and Erika. We really wanted to have something very cinematic in that way. Here you can also see the fluidity of the flow, in fact, of the game. We really wanted the player not to feel he has to jump from one place to another, but just to feel a sequence of action, all one after the other, very, very fluid, very cinematic. And yeah, some of the fight, as I said, at the end of the combos, we wanted to have some cinematic camera shots. So that's what we wanted to do on Prince of Persia. So we had very high needs compared maybe to Assassin's Creed, where there are less situations to handle. And yeah, that's it. So yeah, fluidity. We also wanted the player to feel emotions, to feel some feelings, to have some feelings for the prince or for Erika. And also, as I said, art was very, very important during the whole production. So how do you do a camera engine? What is supposed to be inside a camera engine? First, as in the cinema industry, we have a camera language. We have a set of behaviors that the player understands implicitly, and it helps the player to apprehend the world he's in. So I'm going to talk a bit about the similarities between the cinema language that there's in the cinema and the video game language. So first, the base mechanics. In the cinema, it would be the hardware, the camera, the object, the camera. So we have what we call the free roaming camera. It's a third-person camera. You have it in all of your games. And it looks like something like that. You can turn the camera around the player. You can move it up and down on a curve. So this is something you'll find in many games. And this is similar to the hardware that you would have in cinema. The first-person camera is even more obvious. It would be in cinema industry. It would be a handheld camera. So this is a camera like this. You're inside the player. You can move along the Euler angle, so pitch and yaw. And the right stick is mapped to the movement of the camera. So that's it. Another kind of camera that you'll find in many games is the camera which is based on a spline. So this is TMNT, another game from Ubisoft. And you can see here that the position of the camera is always fixed on a trajectory. So it's a very cinematic way to shoot your game, but of course it implies that your game is very linear and you always know where the player is going to be. But this is another kind of mechanics that you'll find in many games. And in the cinema it would be a rail camera. Other than that, we have also some implicit behaviors. So in cinema, it would be the cinematographic language. So when you have a dialogue between two people in cinema, you have one camera shot behind the first character and then behind the other, and the spectator understands that there's a dialogue between those two. So we have some rules like that in video games. For example, the character offset. In that game, you can see the character is put on the left of the screen, right here, so that we have more space on the right, and the player understands that there's something happening on the right of the screen. So this is something also you'll find in many games. There's also what we call at Ubisoft the Mario mode. It's not a very good name, but it's like in Mario 64, when you had the camera only going back to the back of the player when he moves. So it's very simple. Like here, the character moves, and the camera always tries to go behind him. So this is something, as I said, that you'll find in many games. Another thing that you'll find is the montage. It would be the movie editor in the cinema industry. So you can have level-specific camera shots. For example, you arrive in a zone and your camera switches to another camera angle, and then it shows that zone in a better way for the player. Another kind of montage would be time editing. So, for example, that scene of Assassin's Creed where you have a camera shot here, another here, and another one here. This shows. This is only based on time, basically, so you all know what I mean. And also, that's a difference with the cinema. We can trigger some camera shots in specific gameplay situations. So, if you have a fight, for example. Here, the princess is going to attack the monster, and as you can see, the camera moves a little. It shows the action depending on what the player has done. So this is another kind of control that you have to give to your designers when you do a camera engine. And the other things that you'll have to do in a camera engine anyway are going to be collisions, controls. You want to have smooth controls at all time. And transitions. There's a lot of transition, obviously, in video games. And of course, all of them must have a certain level of quality. So where's the problem? Why can't we all do those features, and why can't we reuse all those features between our games? The thing is, we realize that there are many game-specific recipes that are. It's very easy to do something very game-specific in your camera. So that's. I'm going to give you an example. When our prince turns on spot, so we have a move where the prince is going that way, and then it just turns that way, and the player goes the other way. It's very simple. But the Mario mode actually, it was a problem for us, this very specific move, because the magic box was moving a little. And the angle of the prince is turning 180 degrees. And during that very, very small amount of time, the camera had a very small movement. And as you all know, your designers are going to find it and you won't get away with it. So we had this very glitchy move, which was very stupid, but we couldn't do anything else than just say, is the prince turning on spot? If so, don't go back behind his back. So, as you see, it's a very simple problem, and the only simple solution that we can come up with is asking, is the prince doing that move? So it's already game specific. It's a stupid example, but when you start doing things like that everywhere in your code, you end up with a code that is just not usable and by any other project, and when you share your code, you'll have to extract as much as possible all those very game-specific features. So there's little reusability, mostly in camera engines because of that problem. Another problem that we have in Ubisoft, I don't know if it's the same for you, but our programmers, our artists, when they do the camera on one project, they tend not to do cameras on other projects. So there's a little documentation. Knowledge is lost at the end of the project, and we end up in the situation that we had where we couldn't really understand what the code of Assassin's Creed was doing. So that's why we have to find a better solution. And the solution is to think of your camera system as an engine. So you have to think your system as reusable as possible, as flexible as possible, and you have to give the power to the artist. So the camera system really should be like a toolkit. You give that to your artist, and your artist can say, okay, in that situation, I want to film it that way. And it's very important that it's your artist that chooses to do that action. It's not your programmer. So when the artist has the power to really film the game as he wants to, that's where you have a camera engine that can be reused in many different games. So the global design of our engine was made that way. We had the mechanics. This is what I explained to you, the third-person camera, the first-person camera. All those cameras are mechanics. We had the mechanics system. We had a triggering system that allows to do the montage. and a transition system. They are very separate systems, and it's very important, especially between mechanics and triggering. You don't want to have those two systems at the same place. When you have something like that, you can have one game choosing his own triggering system, and then you can have another very different game doing his own triggering system, and you can reuse the mechanics as long as it's not mixed with other systems. So first, I'll talk about the mechanics. For Prince of Persia, for our engine, one camera shot was one camera object, and so one camera mechanic. You can see here we have a camera that is active. It's a fixed camera, so it would be a camera somewhere in the world not moving. Then something happens. There's a trigger, anything. And we start to activate a new camera, for example, a free roaming camera. So these two are two mechanics, two different mechanics. And in the middle, we have a transition, which is even another mechanic. So in action, that's what you have. So first, this is a very simple movement we have in Prince of Persia. We have it everywhere in the game. So the prince is running on a wall, he's jumping, he's grabbing a ledge. That's it. Hopefully you haven't found any transition in this. And actually there were many, many different mechanics in that very short sequence. So I'll pass the same sequence in slow motion and with some debug info. So as you can see here, the prince, he was on the ground, he jumps on the wall, and on the upper right corner, you may see that it's called ground camera, parent ground camera. This is the camera that we use on the ground most of the time. So we're in the ground camera, and we arrive on a wall. When we reach the wall, there's a transition. The camera has changed. It's a transition to a crack camera. The crack camera is a bit different because it moves on the right when the player goes on the left, and vice versa. And that's it. We're in the transition. The transition is over. So now we're in crack camera. We move towards the left. The prince starts to lean at that point. When he leans, there's a lean camera. The lean camera is a bit different. It's fixed. You don't have the control. You can't move its position. When you touch the controls, you can only change the Euler angles. So you can watch on the left or on the right. You can watch up and down with the pitch and yaw. So here we're in transition, and now here we're in the lean camera. We start to roll run, so that's another transition, and now we're in wall-in right camera, and now we jump to another camera. This is wall-in left camera. We're still in the transition, but you can see what this camera does. It takes the player, puts it on the left of the screen because we're not interested in seeing the wall. We're interested in seeing the space on the right. So this is another camera, and once again we reach the ground, and we're back on the ground camera. So as you could see, in that very short sequence, we had many different camera shots. So that's the granularity that we've chosen on Prince of Persia. So one camera shot is one camera mechanics. This is one mechanic, this is another mechanic, and this is another one. Having this decomposition allows us to decouple the gameplay from the camera. What I mean is that with one camera mechanic, we can use it in any situation. So as I said, we have a fixed camera when we are leaning. A fixed camera is used in our levels in order to show anything in the map. We want to show a specific element to the player. We use a fixed camera, and this exact same camera could be used in the leaning situation. So this thing is very powerful because you don't have to create one camera for each of your actions that are going to be in your game. Remember in Assassin's Creed there was a horse camera for where you were on a horse. There was a low profile camera. All of these things were really gameplay related, and what we can do is we say we want to use a free roaming camera in the horse situation, or we want to use a fixed camera in another situations. So that's the kind of granularity that you want to have in an engine. So let's look at those cameras. In Prince of Persia we had 17 different mechanics. So these are 3 cameras that I explained to you. And as you can see, between the fixed camera and the spline camera, there's a lot of similarity. The first one being you always know exactly where your camera is going to be. In the case of a fixed camera, it's in a point in the world. In the case of a spline camera, it's going to move on the spline, but you always know where it is. The second similarity is, for example, you can move, in those 2 cameras, you can move the camera along the Euler angles, so pitch and yaw. And that's a feature you'll have to do in those 2 mechanics. Then we have the free roaming camera. The free roaming camera is a bit different from the others, but still it shares some features with the fixed camera. For example, you can say to a fixed camera, please change the field of view so that you always see this and this target. This is something you could ask to any kind of camera, a fixed camera or a free roaming camera. So once again, here you have a feature that is shared between 2 different mechanics. Then we have the animated free roaming camera, which is very similar to the free roaming camera. We had the dual camera, which we used in the fight. The dual camera has a lot to do with the fixed camera because you can move along the Euler angles too. It's also similar to the free roaming camera in its movement. So I'm not going to do our 17 mechanics, but you get the idea. There's a lot of features that you can reuse between all those mechanics. And when you have something in C++, like when you have a big hierarchy of classes, this is something that is really, really used to do. It's used when it's difficult when you're in one. When you develop a feature for one specific camera, if you want to add that features for other cameras, it becomes very difficult, and you have to juggle with all those classes that you've made. So what we've chosen to do is to have an architecture that is more flat. It's really we have two levels of hierarchy in our camera classes. So the architecture is like that. The camera is a black box. You give it some target position, some target speeds. You give it controls, inputs, and you give it any information you want. And it outputs one position, one orientation, and a field of view. By the way, just the orientation for us was quaternion, so it's possible to do a camera only with quaternions. So inside that big black box, what we've done is we've divided the camera mechanics in modifiers. The modifiers are very small classes that do a very specific operation on the camera. Each modifier has its own data, so our artist can go and tweak each modifier separately. Each modifier takes the target position, the input. It takes that as input. And there's a communication process between all those modifiers. It looks complicated, but it's really simple. It's just one modifier is going to do a very specific operation, for example, on the camera position. It's going to give its result to the next modifier, which is going to do its own process, and so on. So here's a very simple example, the fixed camera I was talking about. The first modifier that we have is the base position orientation modifier. This modifier allows us to say, put the camera on that place and just don't do anything else. It's that simple. So the result is something like that. You have a camera in a world. The prince or the princess, they can do anything and the camera doesn't move. It just has a fixed position, a fixed orientation. Another modifier we can add after that is the follow target modifier. This one is we're gonna say basically change your orientation so that you always look at the prince. And the result is something like that. The position is fixed, but the orientation always looks at the prince. And then we can have another modifier like the roll modifier, which is very simple. You add a roll angle to your camera. So yeah, that's the architecture that we've chosen. And it's very simple for a case like that. But with all those modifiers, this is our free roaming camera in our final game. So there's about, I don't know, maybe 15 modifiers here. And they all do a very specific operation. Some of them are game specific. Most of them are not. And the end result is that. We have a camera that is going behind the player. We have some target offset. So when the player goes on the left, for example, here, You could see the player, we put it a bit on the right so that we see more space on the left. It's more fluid for the player. We have one modifier, for example, that handles the controls. We have one modifier handling the collision, another handling the collision anticipation when you're not in a wall, but when you're going to reach a wall. We have something that brings the camera a bit closer to the target so that it's not obvious, the change. So this is it. This is our full main camera. So even with an architecture like that, you can do some pretty complicated stuff. So the benefits is the fact that all those modifiers are very easily extractables. It's very easy to take one modifier and put it in a totally different camera mechanic, and you're going to be able to create your mechanic by only choosing which modifier and to use, and then put them in the list of modifiers. It's also very useful for game specificity problems. You can very easily do your own stuff, very game specific in one small modifier. And for example, the example I had where the prince turns on spot. In that case, we've done a very simple modifier asking, is the player turning on spot? If so, don't go back behind the target. And that's it. That's very quick to do those kind of small features. And you don't mess up your code, and in the end, you have the possibility to reuse that code in other games. Overall, in Prince of Persia, we had about 33 or 45 modifiers, and only 8 of them were game-specific. So even if you think in engine terms, you can really come up with solutions that are not related to your game. And that's something you may not realize when you do a big camera class handling all the situations in the same zone of code. And it's a bit more obvious when you do modifiers. And of course, it allows to share your code. The difficulties is exactly the fact that you have to think in engine terms. You have to split up your mechanic in different modules, and it can be pretty hard to do, especially when some modifiers are in conflict. So for example, you can have one modifier trying to bring the camera on the right and another modifier trying to bring it on the left. In that case, you have to handle that situation. You have to have some kind of priority system, or you have to come up with solutions in order to handle those situations. This can be quite tricky. And also it forces to think in engine terms instead of when your game designer comes and says, okay, in that situation I want that behavior, it's very easy to do some code for doing that. It's a bit more difficult when you deal with modifiers. So that's it. That's our mechanics. Then we had the transitions, and as I said, we had some pretty high expectations for Prince of Persia. We wanted the transition to be very fluid. So this is an example of what we had. The princess is going to attack, and there's a transition here. Hopefully you haven't seen the transition, and it's really hard to arrive at a mechanic system that allows you to have those fluid transition at all time. And what we realized is that the transition is nothing more than a mechanic, and there's no magic formula. So this is the modifier, the parameters that our artists could tweak in a transition. There's a lot of them, and we don't have any magic formula. We don't have any super duper algorithm that allows the artist not to tweak anything. The artist is always going to have to tweak those things. He'll have to tweak the transition time. He'll have to tweak the blend in, blend out curves, and many things. So the key for us was to give the control to the artist. Give them the control on the mechanics with all those parameters that I explained, and also when to use those mechanics. So one of the things that your artist wants to do is to use, for example, when you arrive in a certain situation, when you activate one camera, you want to use a transition that is going to last for 1 second. And the thing is, it's going to work in most of your game, but in one specific area in your game, it's not going to work. And your artist will have to be able to say, in that situation, I want to use a quicker transition. So that's the other kind of control we allow the artist to change. So yeah, that's it for transition. If you have a question, we'll be able to talk about that in the question part. For triggering, you remember we had the mechanics, we had triggering, and we had transition. For triggering, we had to have a system that is gameplay driven. Why did we have to do that? It's because Prince of Persia is an open world kind of game. So if you do a wall run somewhere in the world, you'll be able to do that same action anywhere in the world. And you have to be able to allow your artist to specify all those situations in one place. So it's very gameplay driven. So there's a variety of situations we wanted to handle. I'm going to show you the example of the fight. We are going to project the enemy on the wall. And in that situation, we have another camera shot. It's a scripted camera. It shows the prince in a very cinematic way, and it ends on the left of the prince. So this is all those situations. We had many combos in the game, and we wanted to be able to film all those situations differently. Another thing we wanted to do is to have a variety of camera shots. So you saw this action, you saw the scripted camera, and here you're going to see the same action. You're going to see the same action, and actually it's going to be a different scripted camera. So we also wanted to have that variety, so the player doesn't see always the same camera movement, and he doesn't have the impression that we always do the same thing. So this is another thing we wanted to do. What we've done is we tried to create a tool for the artist that allowed them to have that flexibility to film anything they wanted gameplay-wise. So we called it the decision graph. It's not a very good name, but what it is really, it's a hierarchy of states, like any programmers would do. But the thing is, it's the artist that creates that hierarchy. So if the artist wants to film the fight in a different way than the magic powers or the exploration, he has to create that hierarchy. So this is a very simple example. Then in the fight, you can have different combos. In combo A, combo B, and combo D, you want to film things differently in all those combos. And in combo B, you have the start of a combo that you want to film maybe with a free roaming camera, and the end of a combo that you want to film with a scripted camera. So this is exactly the control that our artists had in Prince of Persia. And once you define your situation, for example, the end of combo B during the fight, well, here you can have one camera shot, you can have another camera shot, or any number of camera shots. So a graph is really a set of rules, and each rule is one block in the graph. And one rule is only a bunch of conditions and a bunch of treatments. In our case, a treatment would be only activate the camera. So, for example, for programmers, it would be something like, if we're fighting and we're performing combo B and we're at the end of combo B, then trigger that scripted camera. So this is as simple as this. So as programmers, the only thing we had to do is create those conditions, and then the artist could do whatever they wanted to use them, and they could really have the flexibility to film very precise behavior the way they wanted. So the pros are, it's a visual tool. It's something the artist could understand in, the first time they see it, they understand it. You don't have to handle priorities or to deal with any kind of problems like that. So it's very useful. It's also very scalable because for the example of the fight, for most of the production, we said we don't want specific moves for specific camera shots for the fight. We only want a special, a fight camera, and it's going to be good for most of the time. And then at the end of production, when we started to add all those combos, then we could add them and iterate on them, and it was very flexible, very scalable in that way. It's also very quick to iterate because it's all data-driven. But there are some problems. The first problem being that as you give the total power to your artist, they can do something pretty complex, and it can affect your performance. So as you see, on Prince of Persia we had about 400 gameplay rules. So they were active at all times. At all times we were asking, is the prince fighting? Is the prince doing combo B? And of course there were optimizations, but in the end it's a lot of data to handle. But we had to do that because we have so many situations we want to handle. We had all those transitions between states when you're running on a wall on the right and you jump from the wall, you arrive on something else. We have many situations to handle. And in all those situations we had up to 20 different camera shots that we could trigger. And overall it's about 750 variants of the same cameras. And we had to do all those things because it's an open world structure. So, the good thing is it was flexible and it was all controlled by the artist. Which brings me to the next part, which is the artistic workflow. We had on Prince of Persia what we call a camera artist. I don't know if you have the same kind of artist in your games, but actually we had more than one artist. And it's for a game like Prince of Persia, when you have so many things happening, it's important to have those dedicated artists. So a camera artist is a game designer. He has to understand how the camera shot is going to affect the gameplay, the player. He's a level designer because he has to show the next gameplay elements. He has to understand the flow of the levels. And he's, of course, an animator for all those scripted cameras. So this is a big position in our project. And the goal here was to really give them a toolbox, and then they can go crazy with it. They can do whatever we want. So that was the goal of the camera engine. So what we call the camera toolbox is a bunch of tools. We had this decision graph tool that I told you about. We had the animation tool. Basically, it's 3D Studio, and you can do any kind of scripted cameras in it. We have some trajectory tools for the spline cameras. We want to have a lot of flexibility in our game engine in order to be able to specify all those beautiful trajectories. The transition tweaking tools also I showed you. It's all those parameters and all those situations that our artist could come and say, okay, I want to use these settings in that situation. And at last, it's a mechanics tweaking tool. So it's just, I'm just going to explain quickly. It's just the mechanics. Really, when you're in one camera shot, when you're in one camera mechanic, how do you give them the control over that mechanic? Because there's a lot of modifiers, there's a lot of parameters to tweak. So the thing is, we really wanted them to be able to see what they were changing. There's a lot of abstract stuff when you modify a camera. There's values that modify, I don't know, the damping factors and things like that. So it's not obvious. When you change a value here, the result is going to be very, very hard to understand. So we really wanted to have a direct manipulation. When they change something, and they don't have to relaunch the game, or they're in-game and they can just tweak anything and they see the result in real time. So that was the first thing. The other thing is I want to show here is the debug display. So here you can see our free roaming camera, some of the displays we had on it. And actually it's very, very important. It's something you have to, in my opinion, you have to have it for your whole game. If there's a bug in the debug display, fix it before the end of production. Don't let it go, because it's much better for everybody. It's good for the artists because they understand what they do, they understand what they change, and of course it's something that is good for you, for a programmer, because he understands what's wrong in his code, where it went wrong. So as you can see here, we have the curve of the free roaming camera, and the artist could change the values directly. He could even click on each point of the curve and modify it by putting the camera inside it. So we can really, he always knows exactly where the camera is going to be on the curve. So this is a good thing. You could have the same thing with a mathematical representation of a curve, but it's harder to tweak. And the other thing you can see on the upper left of the screen, it's those bars. Those bars, we use them as a display tool for the artist. So they represent very abstract stuff. So we have one called turn-on-spot attenuation. Actually, this is the way we represent the damping factors. So when an artist modifies a damping factor on a floating value, well, you can't display it. You can't display it in the world. It's not a point that moves in the world and that is damped. It's really a floating value that is damped. So in those cases, we represent it as a bar like this, and we can always show where is the ideal value, where is the damped value, and the artist could very quickly understand what he did when he did his change. So yeah, that's the thing I wanted to say. On Prince of Persia, we had about 3 years of production, and we had up to 4 camera artists at the same time. So in the end, that's those awful numbers, more than 2,000 camera settings. That's a lot, and you have to give them the tools to handle that very huge number of different settings. So we've created some tools, some instancing tools, for example, where they could create their own hierarchy of cameras. So they had, for example, the ground camera, and then they could do very specific variants of that same camera. And when we change something on the parent camera, that change is applied to all the instances of that camera. And actually, that's very important when you have that number of different cameras. We had about 800 animated cameras, so that's also a big another layer of complexity, because those cameras are animated in max, so that means 800 or more max files. So yeah, this is a complexity that if you do a camera engine and you want it to be reusable, you have to give the artist a way to handle that complexity. And also, as we had 4 camera artists, we had to make sure they could work at the same time on different cameras. So yeah, sustainable development. Hopefully you understand what I mean when I say that a big production values project like Prince of Persia, it means a big production. 4 camera artists is a lot, we know it, but it was just unavoidable. We couldn't do differently because there's so many needs in a game like this. So there's a complexity that is, you just can't do a big game like that without that complexity. So the key is to think of your camera features as an engine, really, and to think at all time of the flexibility of that system. The scalability, if you have one more artist, is it going to still work that way? Do we have to change the workflow for that? And the reusability, because as I told you, we want to create those features, but we don't want to do them over and over again on all the projects that we're on. So if you think about an architecture that allows you to reuse your code, well, that's a good thing, and I think I'm pretty confident to be here and to explain you all those things today, because in the end we reuse those camera features in different projects. So there's Sean White snowboarding that uses the same system, and there's more than 3 projects using the same system right now in Ubisoft. So yeah, that's a good thing. And that's it. I hope you like the presentation, and if you have any questions, please feel free to ask.
Hi. With these cameras being used in so many different gameplay situations, I was hoping you could talk a little bit about the techniques that both that programmers and artists use to avoid introducing problems in specific areas of the game when iterating on the camera. Like, say you're in one area tweaking the camera to look really good, but what you don't know is that in another level, this is now made that the camera will actually get into a bug state.
Yeah. The thing we had is that we could have level-specific cameras. So we could trigger other cameras when the normal camera, if you will. When this camera doesn't work, we always have the possibility to override it, if you will, by another kind of camera. And it can be really the same camera. So for example, if you have the free roaming camera that's 3 meters away from the player, and then you arrive in a corridor or something where it's just too far away from the player, in that section we could add a camera zone, and we could take the exact same camera and just change the distance between the player and the camera. And in that situation, we could, have one camera used everywhere in the game, and except some specific areas. So that's the way we solved it.
So sorry, a clarification on your answer there. That implies that you had triggers that could modify only specific characteristics of existing cameras.
Triggers that modify, sorry?
Like in a level, for example, the player could enter a specific area of the world, and as soon as they enter that area of the world, that triggers the camera that is currently in operation to be modified in only just one data field, potentially.
Only one data from the camera?
Yes, you're not swapping out the whole camera. You're just changing a single.
No, we didn't have that because actually the transition system was strong enough to allow us to just switch the camera mechanic. We didn't change just one small parameters inside the camera.
Okay, that's interesting. And then my real question was, you alluded to having 2 camera modifier objects that sometimes they can fight. One wants to go left, one wants to go right. How did you deal with that? Did you just avoid it entirely and say the camera designers need to just not do that? Did you have some kind of arbitration modifier? What was your approach?
Most of the time, when we had those situations, there's one modifier that is more important than another. Mm-hmm. So, for example, we have the Mario mode modifier. It tries to bring the camera behind the player at all times. And we have the polar controls modifier, we called it, which handles the controls really. And actually the controls are more important than going back behind the prince. So in that case, that's the way we handle it. We saw, okay, the 2 modifiers try to do the same thing, but one modifier is more important. And most of the time we could get away with that.
And the camera designers then authored that priority by saying this one's on top, this one's below?
No, it was on the programming side because we didn't have the need for it. But it would be possible, yes. It would be possible to say that modifier is more important than this one. And actually, that's the way it's done in the code. Yeah.
Earlier, I was at the Fallout 3 presentation, and he mentioned how they had developed some of their own technology in-house, and now they were starting to distribute that as tools so other people could use. I was wondering if as you mentioned that you started to adopt the node system, it didn't work. You guys really started from scratch. I was wondering, is this available as a tool that other people can incorporate, or is that anywhere in the plans?
It's in Ubisoft, and it's for now it's specific to the Scimitar engine. Actually, the good thing is that this engine is used by many projects right now. So we only offered that level of control.
So it's part of the...
And we really rely on the architecture of Scimitar. It's very dependent.
Thanks.
Hi, yeah. I was wondering how you dealt with collision between the camera and the environment, and also collision between the view of the player or the other targets and the environment.
I didn't hear very much, but it's the collision, your question,
yeah,
how
collision.
we handle it? Well, there's one modifier that handles the collision, and some modifiers. So the main modifier, the main collision modifier, it's just on the line between the target and the camera, and we try to bring the camera closer to the player when there's a wall. It also handles the occlusion, so if there's an object between the target and the camera, the camera it tries to go behind, in front of the target, of the object. But we had also other systems. So this is a very simple system. I think we have one raycast and one sphere cast, something like that. And then on top of that, we have anticipation systems. So the way we did it is we did it with sphere cast, I think. Many sphere casts to try to anticipate if we're close to a wall and we try to bring the camera on the wall. well, we know we're going to be in collision in a very few seconds, so we try to bring the camera closer to the target in those situations. But it's all done in different modifiers.
Thank you.
So I was wondering if you could talk a little bit about multi-target situations where you have, like in the dueling or something, where you've got like the prince and you've got the enemy and then you've got like this third character and you kind of want to see all of them, but if you like centroid it or if you have like different modifiers kind of looking at each one, you might wind up looking at nothing.
Yeah, the thing we did is we have one target system that can just target the barycenter of different targets. That's the first thing. And when we want to be sure that our targets are in the frame, there's another modifier handling that. And the thing this modifier does is only try to go back and until it sees all the target, or try to adjust the field of view until it sees all the target.
So was the targeting system like a single modifier, or was it a subcomponent within your camera system that then had its own modifiers?
No, the target system was not one modifier. It's just another object. We can pass it as many targets as we want. It returns basically a position and orientation, some speeds, and that's it. And we could use this information in many modifiers. I don't know if that's your question.
Yeah, that's good enough. Okay, thank you very much.
Okay, you're welcome.
You mentioned transitions having periods, like they take a certain amount of time. What'd you do if another transition was triggered while you were in one? Did you transition from a transition, or was it?
Yeah, that's
queue them up?
The fact, as you could see, there's many in a very small amount of time. There's a lot of transition. So our system had to handle that's cascading transition. So we really could transition from anywhere in the transition, and we could have a pile of transition. It was pretty much transparent because we don't rely on. If we have a transition, for example, between camera A and camera B, the easiest way to do that transition is to update both cameras and just interpolate between those two. But most of the time, when you decided to go in camera B, that means that your camera A is not good enough. So if you keep on updating your two cameras, the camera A may have a behavior that is erratic, and in that situation, the transition will be messy because it's going to rely on an erratic transition. So what we did is when a transition is triggered, most of the time we say to the first camera, stop updating, and we predict where the camera would have been if it would have continued its movement. And from that predicted position, we transition. So that's the way we achieve that many cascading transition in the game.
Thank you.
Hi, I have a question about, have you looked at what sort of challenges you would have if you wanted to extend your system for a full 3D display?
For a what?
Like a full 3D display, like the new 3D goggle set that NVIDIA is putting out.
Oh.
They're taking these a lot of games and doing some sort of camera tricks to get a nice 3D display. Have you looked at any sort of, I want to have a 2D version of this and a 3D version?
No, we didn't think about that problematic.
All right,
Sorry.
thank you.
So, if you have any questions, we still have some time. I don't know. And otherwise, you can still come see me, and I'll be answer. Oh, we have a question.
So this is really quick, but I'm curious, was your post-processing driven by your camera system?
Post-processing, like
depth of field, bloom?
No, actually, the depth of field was done by the FX team, and we didn't have to do anything with that. We could have done it because it would have been really useful, especially in the case of depth of field. I would have loved to have that control, but the reality was that depth of field was a bit too much for the whole game. So we only activated it in certain situations, and I didn't have the control over that thing. But that would be doable with a modifier very simply, because you can use really the camera system and you can understand in which situation which depth of field is useful. It could have been done in the modifier.
So I guess this is kind of on top of it. Like, you said the camera was a black box. Like, how much data was it responsible for actually like producing for the rest of the system to sort of consume? Like, was it just like a bone, basically, like a position, orientation, and like maybe FOV for itself, or?
Your question is what we gave to that black box?
No, actually, what was sort of the output of the black box that the rest of the system could ask about? Like, I'm assuming that, at least at some level, avatar control cared where the camera was. If you were like, okay, like up means, away from the camera, or down means. So like other things probably were able to see the output of it. And like, I'm assuming that somewhere your post-processing system wanted to know what the FOV was, so they could adjust the depth of field a little bit, maybe. I don't know. But
well, basically, the other system could query the position, the orientation, and the field of view, and most of the time we didn't need anything else. If we need a target position, the target system is totally different from the camera system, so they could use their own targets, and that may be the same target. The camera could look at the prints, and the depth of field could look at the same target, but it would be two different objects. So they don't have to query anything from within the black box.
Okay. Thank you very much.
You're welcome.
Hi, Leo Chan from EA. I'm just wondering if any of your camera modifiers saved frame-to-frame state, because I'm just thinking about replay cameras, if you have to do anything like that. Did you save any state in your modifiers?
No, we didn't have the need for that, but that would be possible to do it in one modifier. For example, it would be a modifier at the end of the whole chain of modifiers, and it would be able to record the last position and last things like that. But
right.
we
Just
didn't
to
have
be clear, I'd actually discourage the saving of state, because then you can do replay cameras. So it's good to hear that you didn't need state,
no.
frame-to-frame state.
No.
That's good.
So you mentioned that you had a debug view that would allow your camera artists to view what the ideal camera would be versus the actual attenuated camera. Were there any other debug visualizations you found your camera artists needed, or was that sufficient?
Actually, each modifier had its own display. So that's the key, because you don't want to see all those information on your cameras. When you have 15 modifiers active at a given time, you want to organize your debug display. And that's also very simple for the artist, because he only wants to see his curve. So he goes on the modifier that does this curve job and displays it, and then he can modify it. So, yeah. So that's it. I release you. Thank you.